Welcome, everyone. In this section of the course, we're going to get into some of the fundamental concepts and features of Algorand. The goal is to teach you everything you need to know before getting hands-on with some code. So before you start writing smart contracts, testing your smart contracts, or using AlgoKit to interact with the blockchain, we're going to lay some of the basic conceptual groundwork so that you can really hit the ground running. The first thing we're going to talk about are Algorand Standard Assets. So, what are Algorand Standard Assets? They're digital assets that you can create directly on the Algorand blockchain. And what's cool about them is that they let you represent all kinds of digital assets. So anything from fungible assets like stable coins or loyalty points to unique assets like NFTs or property deeds can be deployed directly on the network. And the key benefit is that ASAs are built directly into the Algorand protocol. So it's a layer one feature or a primitive of the network. And that means that there's really no need to create complex smart contracts or otherwise any complicated code to represent an ASA. You can deploy them with just a few lines of code, and we'll see that later on in the course. Let's break down some of the features of ASAs in a bit more detail. Like I mentioned, they're built directly into the Algorand protocol, so no smart contracts needed. You can create both fungible tokens like currencies and non-fungible tokens like NFTs. And ASAs also come with optional fields like the manager, reserve, freeze, and clawback fields. And what these let you do is they really allow you to control how the ASA is managed. So, for example, the manager field lets you update certain properties on the ASA. If you set the freeze field, you can prevent the ASA from being transferred by a specific account. And this is useful for certain use cases where you have regulatory requirements. But it's important to note that these fields are optional. So if you want to make sure that an asset can be freely traded or that the properties will never change, you would simply leave these fields blank. And another thing to know is that creating an asset increases an account's minimum balance by 0.1 algo. So that means if you want to create an ASA, you have to make sure that you have a minimum of 0.1 algo in your account. And this is known as the minimum balance requirement, which we'll cover in more detail here in the next few slides. And the last thing is that to receive an ASA, you have to explicitly opt into it ahead of time. So essentially, if someone wants to send you an ASA, you have to opt in first, and then once you opt in, they can send it to your account. And that's really to prevent people from just like spamming your account with random assets. Okay, now let's talk about transactions. Transactions are really the backbone of interacting with Algorand. They are essentially instructions that you send to update the blockchain state. So if you send algo to another account or if you create an asset, you do so by sending transactions. All transactions follow the same flow. The first step in that flow is you create a transaction. So if you want to send one algo to Alice, you would build that transaction using code. Then you would sign that transaction with your private key. After you sign it, you would submit it to the network. And then it goes through a consensus process where basically the nodes in the network decide whether or not to add the transaction to a block. And if the block is validated or approved, then that block gets written to the blockchain, and then the state of the blockchain gets updated. And so transactions really power everything on Algorand, anything from sending payments to making smart contract calls or creating assets. That all occurs through transactions. Algorand supports several transaction types. So each transaction type has a specific purpose, and we're going to cover those here. The first and most common transaction type is a payment transaction. And what that really allows you to do is to just send algo between accounts. Asset config transactions allow you to create, modify, or destroy assets. Asset transfer transactions are really similar to payment transactions. The only difference is that instead of sending algo, you're sending ASAs. Asset freeze transactions control whether an account can move a specific asset. So like I mentioned before, this is really something that's used in or that's useful for regulatory use cases. App call transactions are what you use when you want to deploy or interact with a smart contract. So if you have a method on a smart contract that you want to call, you would send an app call transaction to that app. And these last three transactions here, key registration, state proofs, and heartbeat transactions, those are related to how the network operates. Key registration transactions allow you to bring an account online. So it registers the account as online to participate in consensus. State proof transactions are used to keep the history of the blockchain secure. And heartbeat transactions allow participation nodes in the network to signal that they're healthy and functioning normally. Atomic transaction groups are a really unique and powerful feature of Algorand. What they let you do is they allow you to bundle up to 16 transactions together. And what's important about that is that once you've bundled them together, they execute as a single unit. So when you send them to the network, they all execute together and it's pass or fail. So that means that if you group transactions together and you send them to the network, then they either have to all pass or all fail. This is really great for complex operations like deposits or swaps, where you have a bunch of transactions that depend on each other, because it ensures that nothing gets half done. And another important thing to know is that you can pool transaction fees together in a group. So one transaction in a group can actually cover all of the fees for the other transactions in the group. Okay, let's talk about what happens when transactions fail. So whenever you submit a transaction to the network, the nodes participating in the network run a bunch of checks to make sure that the transaction is valid. And if a transaction is invalid, so if it's a duplicate or if it's a double spend, it gets rejected by the network and it won't be added to the blockchain. The good news, though, is that you don't have to pay any fees for rejected or failed transactions. So this kind of keeps everything nice and fair and prevents unnecessary costs. Now let's get into fees and minimum balance requirements. So every time you submit a transaction, you have to pay a fee. And this is basically to protect the network and prevent spam attacks. Otherwise, you can imagine that if there was no cost to sending transactions, you could just send an infinite amount of them and congest the network, right? Minimum balance requirements are another layer of protection. They ensure accounts have enough funds to participate in the network, and they also act as an anti-spam measure. So basically, when you want to do certain things, like create an ASA or add storage to a smart contract, you have to deposit a minimum amount of algo to your account. Both are really designed to keep Algorand running smoothly and ensures that no one is taking up too many resources on chain. Okay, so here's some more detail on fees and minimum balances. When the network is running like normal, every transaction costs a consistent flat fee of 0.001 algo. But if the chain gets busy and becomes congested, then the fee is calculated using a formula that you can see here on this slide. And the way this formula works is you basically take the current fee per byte, so that's just a set number, and you times it by the size of the transaction. This keeps the fees predictable during normal conditions, but flexible when the network is under load. Okay, now let's take a closer look at minimum balance requirements. So if you're creating an ASA, you'll have to add 0.1 algo to the minimum balance on your account. And same goes for when you're opting into an ASA. So for every asset that you opt into, you have to increase your account's balance by 0.1 algo. You can see here that the same thing applies for creating storage for a smart contract. And yeah, there's a few different actions that you can do on the network that increase the minimum balance requirement on your account. These requirements are really designed to ensure that accounts have enough algo to cover their network activities. It's a way to keep the blockchain efficient and secure by making sure everyone's got some stake in the game, so to speak, and it isn't just taking up loads of space or using tons of compute for free. And it's important to remember that this is a deposit, not a fee. So if you destroy the asset that you created, or you opt out of the asset that you opted into, you get the 0.1 algo you deposited returned to your account. All right, now that we've covered some of the fundamentals of Algorand, let's move on to AlgoKit, which is a suite of open source tools that make it super easy to develop, test, and deploy your apps on the Algorand blockchain. You can think of it as a go-to toolbox for building on-chain applications, whether you're writing code or testing smart contracts or deploying to the network. AlgoKit just kind of streamlines the process so that you can focus on building stuff rather than wrestling with setup. And we're going to take a closer look at what's in the toolbox over these next few slides. There are several tools in that AlgoKit toolbox that make it easier to develop on Algorand. One of the most important ones, and ones that we're going to take a very close look here in this course, are Algorand Python and Algorand TypeScript. And what these let you do is they allow you to write smart contracts in either Python or TypeScript, and that's native Python or TypeScript, and it handles compiling those contracts into a language that the Algorand virtual machine understands so that you can deploy it directly to the network with minimum hassle. Another tool, another really great tool actually, that we'll be using a lot in this course is LoRa. LoRa is a visual explorer that lets you inspect and interact with the Algorand blockchain in a user-friendly way. It's kind of like a dashboard where you can see what's happening on the chain, like transactions, account balances, or asset details. You can use LoRa to visually explore transactions happening on the blockchain, and you can use it to interact with your smart contract as you're developing it. So it's a great way to kind of get a clear picture of how your app is behaving and a great way to test it as you're working on it. And it's, yeah, like I mentioned, really helpful for debugging, and in general, I would say it's great for getting a feel for how Algorand works without diving too deep into code. Another key piece is the AlgoKit CLI. The AlgoKit command line interface is essentially the backbone of the suite. It helps you scaffold new projects, it helps you manage dependencies, and it helps you run tasks like building, testing, and deploying your apps. It's a really straightforward way to handle all of the nuts and bolts of developing your app on Algorand. And finally, AlgoKit Utils is a general purpose library that is used to interact with the blockchain. It lets you create accounts, send and receive assets, and it's also used to generate clients for your smart contract, which makes interacting with them super easy. AlgoKit also ships with super useful tools for testing. As a big part of that is LocalNet. LocalNet just spins up a private network on your machine, letting you test apps in a safe and isolated environment that mimics a real chain. So it mimics mainnet. Everything you do on LocalNet, you can expect it to behave basically the same way as it would on testnet or mainnet. AlgoKit's Python and TypeScript unit testing libraries emulate the Algorand virtual machine, so you can test smart contracts without a live network. The AVM debugger lets you step through contract execution to visually spot and fix issues. And finally, the testnet dispenser provides free algo for testnet accounts, making it easy to experiment and develop on testnet. And AlgoKit also includes tools to make deploying your app to Algorand very simple. With commands like AlgoKit deploy, you can deploy your smart contract to testnet or mainnet with minimal configuration. And it's all designed to kind of work seamlessly with the other tools, so your development, testing, and deployment flow feels really nice and intuitive. And that's it. We've covered all of the basics and hope you've got a good grasp of ASAs and transactions and fees and minimum balance requirements. And in this next section, we're really going to get to the fun part, and we're going to start building our own apps on the Algorand blockchain.